Okay students, today we will see the next point, that is standard test inputs. Let us see first the need and necessity of the standard test inputs. First, different input signals are applied to newly developed system for checking its performance and to study the response of the system to this input. That is, whenever we are developing some new system, some input signals are to be used for testing purpose. So that is the first basic need of the standard test inputs. Second is evaluation of the system, which is made on the basis of response given by the system to this input, called as standard test inputs. That is, evaluation of the system is done on the basis of the standard test input signals. That is, what input is given and what output is obtained. Then, for example, testing of television using a pattern generator. Okay. That is, for example, a TV set is there and it is tested by using a pattern generator. That is, how it is tested? Once all the patterns are reproduced by the TV set, then the patterns are then observed and then analysis is done, whether each and every pattern which is obtained is accurate or not. That is, pattern generator is used for testing the signal, that is, it is applied to the TV set, and then various types of patterns are then recorded and then they are tested for accuracy. In this way the TV will be tested. Basically, there are so many test signals available, but only following are used as the standard test inputs. That is, in our syllabus we have 4 test inputs basically. First is step input, second is ramp input, third is parabolic input, and fourth is impulse input. We are all familiar with these signals in your earlier classes, that is in second year. Then too, these signals will be now studied in detail from now. Okay, now what is step input? All of you know. Step input is nothing but a signal which is having constant amplitude throughout the time period. Ramp is nothing but a staircase type waveform, and parabolic is a mathematical equation, that is parabolic shape. And then impulse input, that is, it will exist only at the origin. Okay. Okay, now let us see in detail. First is step input signal. What is step input? A input signal in which the amplitude of original signal changes from 0 to specified value, that is A, in 0 time. Okay, it is called as step input signal. Second is unit step. Only in this the change is the magnitude of the signal is 1, that is amplitude will be 1. Third is ramp input signal. What is ramp input signal? The signal which starts at a value of 0 and increases at a constant value with time is called as ramp input signal. That is, at each every time instant there will be some increment or decrement in the amplitude. It will appear as a staircase to us. So it is called as ramp input signal. Fourth is unit ramp. That is, the change is only the magnitude will be 1. Okay. Then parabolic input, a input signal which is 1 degree ahead or faster than the ramp input signal. That is impulse input signal. What it is? It is basically a short duration of high amplitude pulse. What is this signal? Initially applied at origin, that is at t is equal to 0. It will have only value existing at origin, and on the left side of origin and on the right side of origin we have the amplitude 0. That is, the signal will have amplitude only at the origin, that is, it is existing at the origin. Then 8th is unit impulse input signal. If amplitude is 1, then it is called unit impulse. Impulse input signal can have amplitude varying from 0 to any value, but if the amplitude is specifically only 1, then it is called as unit impulse input signal. Okay. Now what we will do? We will revise each and every signal again with their mathematical expression, Laplace transform and time domain equation. Okay. Okay, let us see. Now let us see first signal, that is step input. As you can see in the figure, step input signal is having amplitude 1 and it is denoted by u of t. Okay, this is unit step input because amplitude is 1. If the amplitude varies other than 1, then it will be called as purely step input. As the amplitude is 1, so it is called as unit step. Its mathematical representation is r of t is equal to a into u of t for t greater than 0, whereas it will be 0 when t is less than 0. That is, the signal will exist only beyond origin, that is greater than values of 0, and below 0 the signal will not exist, that is it will be 0. Okay. Then next is Laplace transform. How Laplace transform is found? A upon S, that is from time domain to frequency domain, when we convert it we require Laplace operator and then it will do the conversion. That is what we are doing, amplitude whatever is there in the time domain, it will be divided by small s. Okay. So in time domain, if it is represented by a into u of t, then it will be a upon s in Laplace domain. Let us see the next signal, that is ramp input signal. As you all can see, it is appearing to us like a straight line which is exponentially increasing with respect to time. At 0 it has some 0 amplitude, at 1 it is having greater than some 0 value, then at 2 it is having somewhat greater amplitude. That is, at each time instant there is incremental value in the amplitude. So the signal is appearing like a staircase. Okay. Then mathematical representation is r of t is equal to a into t for t greater than 0. That is, as you can see, when the time is increased, at each instant the amplitude is going on increasing and it is equal to 0 if t is less than 0. That is, now remaining signals, that is impulse and remaining other signal is parabolic signal, will be discussed in the next lecture. Okay, thank you.